Right. So what I would like to share with you today is how we managed to leverage a couple of popular open source tools and build a quality data warehouse. Bit of context before we get started. Kognic is what you might say a mid-sized company. We are a software company, and we have a mission of making safe perception possible. So we have very mature operational data, and what my team was tasked to do was to take the next step and create and enable the company to do analytics at scale. We have to move within some constraints, and the constraints when we want to be fast in deploying, we want to create something maintainable, because we're a limited team, we only have 2 people on average, and we wanted to try to have a limited budget, meaning favor open source solutions whenever those could make sense. We have an existing setup. We are on GCP. That's our main cloud vendor. We're heavily relying on Kubernetes, and there is a well-established platform engineering team, meaning creating new deployment is greatly facilitated. So you want to create a data warehouse. Where to start? There is an obvious choice. That's BigQuery, since we are on GCP. Everything else is kind of open, right? So if you look at the landscape out there, you have a very broad choice of tools. This is a picture taken from 2022 on LakeFS website, and it gives you a glimpse of how much tooling is out there. So the questions are, what do you pick? Why do you choose it? And do you need it? So we started our journey by trying to sketch the sort of architecture which we wanted to stick to. The idea was to have an ELT approach, having our data sources, loaders in form of Python code, Python apps. So we needed something to orchestrate those, to schedule them. And once data was ingested into the warehouse, we want to handle all of our transformation with some sort of tooling. So creating a curated layer, a staging area, and a data mart, and have our user be able to access the data mart. And ideally have some sort of catalog or data discovery tool on top of it. So the choices became the combination Airflow and dbt, and that's what I would like to focus on today, how we make them work and how we got the best out of it. Airflow is probably a tool that many of you might have at least heard of. It's been around for almost 10 years. It's a very robust open source tool. There are cloud version or self-hosted version. And the core principle here is that your workflow is code. So you just write code, Python code, so very lower threshold to just come in and to create your pipelines. And Airflow will then render the DAG for you and give you a very nice and intuitive user interface so that you can just from that interface handle the most common use case. You can do partial rerun, you can do backfills, you can explore logs, so everything is extremely easy to do from that interface. More than the architecture itself, what I want to share is how we try to maximize the value we get out of it. And we are on a self-hosted version, and our approach was to keep a clean base image. So Airflow has a really large amount of operator and the tools you could use out of the box. What we tried to do was to refrain from using those as much as possible. We have a very strict policy of not having any top-level Python code on it, and just rely on something which is called the Kubernetes pod operator, meaning that everything we do is built into an image, and we just run that in a pod. And why that is good is because then it greatly facilitates handling testing. So we wanted to decouple the logic of what the DAG does from what's going on within the task. And we're a software company, right? And so we have incredibly good CI workflow for testing our app that goes into production. So we as a small team, we could leverage the existing CI workflow for testing our Python apps before they get tested. And what you remain with in Airflow is just the DAG itself. So your tests are only pretty much can keep it under version control, make sure it compiles, and make sure that importing routine do not break. So there was an approach that gave us very good speed, because all we need to worry about in terms of testing is just that the DAG doesn't break. And our experience with it is that the tool works really nicely. It's very robust, and mostly it integrates with pretty much everything which is out there. And most notably with dbt, which what I would like to share in a moment. Those two tools together are a great combination. And where we found it instead to be a bit underwhelming, let's say, is in the versioning part. So you sure can have your DAG under control in Git, but there is no intuitive way right now to have from the user interface, for example, you would like to execute a DAG which was tied to a specific commit. So it's still a bit shaky in that sense. All in all, very robust tool. So even if open source, we could feel confident to push it out to a production environment and have everything depend on it. So we now have a way to orchestrate and schedule the pipeline, data flows into the warehouse. Next step is you want to create some value out of that data, right? You want to do some cleaning, you want to do some modeling, you want to transform it into something that answers your business questions. And there are easy ways to go for it. You're on BigQuery, you could just schedule your queries, you could create your views and just expose them to the user. You can just create your own app to materialize your tables and keep maybe your SQL files just under version control. We try to see if there is a tool that handles everything. So we wanted something that from the moment raw data exists until when the consumer uses it, controls everything. And most important, we want to build some sort of CI workflow around it, so we don't push anything to production which we don't really trust. And that tool turned out to be dbt. dbt is a relatively new tool, although it's gaining a lot of traction during the last few years. You can think of it as the transformation part in an ELT architecture. It does not have any compute engine. It piggybacks on your warehouse or on your database, and it provides you with one source of truth for everything which is created downstream. So the main idea is that every transformation, every table, every view in your warehouse becomes a SQL file that you keep somewhere under version control. You can mix SQL with more powerful languages. You can have templating, you can have Python. And what the tool does for you is to compile all of this in plain SQL and resolve cross-dependencies. So you could have files depending on each other. And then the tool will tell the warehouse what to build, how to build it, and handle all the create, merge stating, and all of that. So the picture summarized pretty much well the philosophy beneath it. Raw data is raw data. Everything else could be recreated from scratch just by looking at your base code and at your transformation into dbt. So all you need to care about now is how do you run it. So you want to somehow schedule it, and in theory, all you need is the ability of running a bash command every day, for example. Could done in GitHub Action, could just have a bash operator in Airflow. We found it to be very convenient to exploit the integration between Airflow and dbt. Airflow provides you with the capability of dynamically generating your DAG based on some manifest. So you don't know what's going to be created in your DAG, but you know what kind of tables you need to generate. And once Airflow can see that manifest from dbt, it will create for you a graph like what you can see there on the right-hand side, where every single table becomes a self-contained task. So troubleshooting, investigating, just have a partial rerun becomes incredibly easier because you don't have just one task running several hundred tables in your warehouse. You have one task per table. So this is how we create tables, but how do we actually develop with dbt? How do we empower our users to have a nice experience, feel confident to come in and use the tool, and yet make sure that we do not push anything to the warehouse which we don't feel confident with. First idea we have and we want to enforce was that everything needs to be code. So if it's not in Git, it doesn't exist and it doesn't make it to the warehouse. And then we try to mimic as much as possible the same approach you might have when you start developing software. So you want, sure, version control. You want a common standard or writing code, so some sort of linting. You want to test. Everything that can be tested should be tested. And you want some form of peer review for sharing knowledge, for example, and peer review of what you're doing. So this is roughly the kind of workflow we have. And before digging into the CI workflow part, something we realized was very important was also that we needed to somehow make it simple for newcomers to come into the tool and write code. And while dbt removes quite a bit of complexity, you don't need to write explicitly, for example, your create statement, it comes with a cost. And the cost you need to pay is that there is quite a bit of templating, quite a bit of YAML you need to include into your project, which is a bit tedious, maybe not super intuitive. So what we introduced was a module called dbt CodeGen. We start using it quite recently. And that's a module that generates in one single line of CLI all the boilerplate you need, meaning that you only care about the SQL transformation you want to write, all the boilerplate, all the templating, and even upstream documentation, which your model might just be consuming, is created for you. So you as a developer, you are consuming someone else's data. You just add a couple of extra metrics on top of it. With that command, you get the documentation of what you're consuming and the templating for adding the documentation to what you are creating. Meaning that you can allocate your time to what matters the most, so the SQL transformation, the business logic you're trying to implement. Once that is done, you're working on your branch, push it to the remote, and that's where the CI workflow kicks in. So the first thing which we wanted to enforce and we thought was extremely important was to have a common standard of writing code. So that's probably self-evident if you're a software developer. In the SQL world, probably is not yet as well understood. So we're leveraging a tool called SQL Fluff. It's a Python-based linter for SQL. So you can think of it as PyLint or Flake8 for SQL. It's very robust. It's been a second major release just a month ago. And it comes also with a dbt templater, meaning that in this overall architecture, everything integrates really well with each other. And what you do is you define a set of rules. So how do you and your team are going to write SQL? What sort of spacing, layout, capitalization, all that sort of thing? What are you going to have as standard? And that set of rules is enforced in the first gate we have in the CI workflow. And a nice plus is that this is also an auto-formatter, meaning that you can fix most of the more common errors just with one line of instruction in the CLI. And the overall result, which we can see, is that the code that you write and you push to production is recognizable. So you can go into anyone else's SQL and to some extent recognize the same way of writing and the same style. So now we have well-written code. Second step is make sure that compile, that will be done by dbt for you. Materialize your tables in the warehouse in some testing area, right? You don't want to push it to production yet. And once those tables are materialized, that's where we start testing. Testing is done at, I would say, 3 different levels in the tool. And there are packages to do all of this, so you don't really need to reinvent anything. First family of tests is just the usual suspects, so to speak. So it comes in the dbt core version. You test primary keys, you test uniqueness, you test not null, that sort of things. What I think that's really interesting is when you start testing the content of your data. So you know your data better than anyone else, so you know what to expect from it. And there is a module called dbt expectation, heavily inspired by the Great Expectation tools, that provides you with a very easy and intuitive way of doing this. So you can think of it as unit test for data. So in unit test, you have your assertions. In data, you have your expectation. So like on the top corner, you can see those are verbose statements, say what happens to the data. Expect column A to be larger than B. Expect table to have recent data. Expect mean to be within a range. So those are one-liner in your YAML file, meaning that you, as a developer, as an analyst, scientist, creating a new data source, just need to write that specific statement in your configuration file. You don't need to spend too much time writing your test, and yet test will be there, and you will be sure that whatever is pushed to production or whatever might affect your model gets tested. And finally, metadata testing. Right? So good data with poor metadata, it's not really great. And dbt comes with a really nice package for testing metadata existing and metadata coverage. And that becomes particularly relevant if you think that dbt is not just a tool for handling transformation. When you handle your transformation, dbt will create for you a catalog. That catalog can be then compiled in static HTML content, which can be hosted on your internal web page. So what you get for free is a full-fledged data catalog. There are some really nice advanced search functionalities. There is complete data lineage you get for free. There is some basic profiling, and you can search for that. You can expose it to your users. You can even tie dashboard to the sources that are using that. In order to make it work, you need to populate the metadata, right? So what we do in the final step of our CI workflow is checking for any modified SQL file and making sure that all the data that gets either created or modified as an empty description, some ownership, and all the columns are documented. So what you end up with, if you take one step back, is a simple way for analysts, scientists, developers, anyone to create data, and a very robust workflow where you check that code is well written, compiles, data is correct, it's up to your expectation, and you have full, complete metadata. And all of this before you push it even to production. So there is no way you can just start throwing garbage into your warehouse. How it is working with the tool, what is our experience? We've been using it for a bit longer than 1 year. We find it to be a great tool. So it's very good from a developer's perspective, having documentation and SQL code kept in one and the same place. That really simplifies life. It's fairly easy to set up a robust CI workflow, like the one I show in those slides. Integration with Airflow, it's really great. And the biggest highlight is probably the amount of packages that are out there, and they just keep on growing. So it's a bit like the feeling you get when you start using Python and there are modules for everything. It's sort of like that with dbt. If you have a problem, likely someone else in the community already solved it for you, and you can leverage what exists. Where things don't really shine yet is the linting part. Linting SQL, easy, works really nicely. When you start mixing templating, Python and SQL, it's still a bit shaky, bit of room for improvement, we think. And logs are improvable. That heavily depends on what sort of warehouse you're using. Logs for BigQuery from dbt are still a little bit suboptimal. All in all, it's a fairly robust tool, and you get loads of functionality pretty much bundled in one and the same tool for free. So besides sharing the technical detail, I would like to share some key learnings. So we went on to this journey, limited team, we wanted to move fast, and we built something. What did we learn along the way? First thing is that it turns out to be a very good choice for us to have just a couple of tools. So limit the amount of tools, get something good enough. Doesn't need to be great, but it needs to get the job done, and it needs to be robust. In that way, if you get something that is limited and yet bundles so many functionality, you and your team can move fast and allocate time where things matter the most, like modeling data, for example, or optimizing your pipelines. Reusing what your company already has, in our case, the CI workflow for building apps. So having containerized tasks in Airflow really allow us to not have to worry too much about that CI workflow. And most relevant probably is start thinking of your SQL as code. So it's no different from writing any other piece of code. So you want to lint it so that you have readability and you have easy maintenance. You want to have some sort of a PR review, and you need to test everything that you can test. So the code itself, the data itself, you cannot push anything to production without testing it, which would be the normal mindset for any software developer, right? And the overall outcome, what we're seeing is that users start gaining confidence in the data. So they know there is a catalog, they know data is documented, and they can just go and search for it. And there is a bit of learning curve for start using the tool, but we're starting to see that users actually now get more and more confident using dbt. So once they understand how it works, they really start recognizing the value and saying, I want to use it because then I can trust what I produce. And a couple of questions that might be raised, looking at everything presented so far, is would it scale? If you tenfold or times by 100 your use base, will it still work as it is? And I sort of half cheated saying that DBT is a data catalog. It's a data catalog for what it produces, which works very well from us. Nothing else can get produced if not from DBT, so transformation and everything is in there. But we will ever need a dedicated governance tool, because the moment you start transforming data in your warehouse with, I don't know, you use Spark, create something else that's not visible to DBT. So it's not a true data governance tool. So with that said, this is everything I had to share today. I thank you for your attention.
Thanks a lot. Maybe we should start with questions from the audience. Do we have? Yeah, one there.
Hey, great presentation. A question, you have shown us the CI pipeline, but what about the CD? Like, how do you, when you merge to the main branch, that means that all of the tests they have run and this is ready to go to production. This needs to make it to production, but how do you also test the data or the new data you have done with DBT with Airflow as well? Like, do you test both of them together, or do you have a decoupled workflow where?
So we have. Oh, sorry. If I understand correctly the question, we have, let's say, 3 levels of testing. There is the one before you merge it, right? So that's just testing on your local branch in a test environment and make sure everything is correct. Then the same test is run on a scheduled way with Airflow. So once data is merged, we produce an artifact that's visible to Airflow, and Airflow knows what to materialize and what to test. And that's tested overnight, just to make sure everything keeps on staying correct. And there is a 3rd level of test, and that's in a production environment, just making sure that stays correct. And then there is a 3rd level, which is more a sanity check, so to speak. So it's testing if something is correct but unexpected. And that's done also in a production environment weekly, anomaly detection, that sort of things.
So then when you have a new DBT configuration file or DBT artifact, you don't trigger automatically an Airflow release. You wait until the end of the night to check that everything is all right.
So when there is a new file modified, we trigger directly, not from Airflow, but from the CI pipeline. We trigger directly a run in production to update everything that could get changed. And at the same time, we export a new artifact to Airflow, which the early morning afterward will then run again towards production.
Thank you.
Thank you.
So I have a follow-up question for that. So it's in your CI flow, it looks like you used some version of Great Expectation, but that is testing the data. But now you're also talking about testing the pipeline. So do you separate those tests?
Yes, data tests are 100% DBT. So in the pipeline, we do not test the data, but the data pushed from the pipeline into the warehouse, it ends as a source, which is visible to DBT. And in DBT, you can test sources. So that gets us cover. It's not part of the pipeline test. It's sort of the step 0 in the warehouse.
Okay. So we have a question in front here.
Thank you. So I was wondering if you have, when you have a transformation where you find that SQL is really not enough, like powerful enough, or expressive enough to get it done, and maybe even if the templating, even with templating, is not enough. Like, do you ever find yourself in that situation, or does it always work? And if you ever do, then what do you do instead?
Partly yes. So we found a couple of edge cases where plain SQL would have been too cumbersome. And what we did was to create either macros or UDF in BigQuery. So you leverage a pinch of JavaScript and some more powerful programming language. And you can still have those visible to, in this case, dbt. So dbt creates for you or keeps updated for you the UDF in BigQuery. So it's still under version control and everything centralized. And that will be the transformation. So compute engine dbt, and on your data, you can do advanced stuff with UDF. Sorry? JavaScript. In the BigQuery case, at least. I don't know in other warehouses what sort of capabilities are there.
Do we have more questions from the audience? So, okay, squeeze in one of mine. So can dbt handle like delta updates? So like delta
runs?
lake?
Yeah.
Okay.
Oh, delta lakes.
Right, no, but delta updates. So you can see that, okay, I'm going to change only part of the data. I'm not going to recalculate everything from the raw data.
It can handle incremental reruns, so you just update partitions. More than that, we never look into, so I wouldn't be able to give you an exact answer.
Okay, so you cannot really do time travel on your data automatically from...
Not with dbt, as far as I know.
Okay. And another question, can you run it locally? Would you recommend it to change, like using dbt instead of pandas, for example, for data processing pipelines?
I would see them as two very different tools. But you could run locally. I mean, all you need is a Python working environment, and you install dbt with whatever template for your warehouse you need, and you can run it from your machine via the terminal. So that could be possible.
Okay. But you wouldn't recommend it, maybe?
Yeah.
Okay. Cool. So, thank you.
Yeah, thank you. Thank you.